Good evening, everybody.
Good
Hope we're
evening.
hope we're all doing well today. Um, let's see. Okay, so has anybody is there anybody who hasn't gotten an opportunity to look at the homework from section 10.1 and 10.2?
I haven't done 10.2.
Okay, yeah, that's perfectly fine. It's still open until Monday. Um, but a lot of what I'm going to do today, um, as we continue in through 10.3, we're going to be talking about linear equations, but specifically we're going to be talking about finding the slope and the intercept, the y-intercept of those kinds of an equation. So if this is going a little bit fast for you, it may be that you just need to, and not you in particular, but any of you who might think that this is going a little bit fast, um, it just might be that you guys got to get into Hawks and practice those homework problems, just so that you know more or less what I'm talking about in class, because it's starting to build up quickly. Um, and it all relies on all of the skills that we built to solve linear equations, because that's exactly what we're dealing with. We're dealing with linear equations and now their graphs, and trying to sort of study what their graphs look like and different characteristics of their graphs. Okay. So today what I want to do is give a lecture and give some some normal example problems like I normally do. But then in between those things, I will be jumping into Hawks so that we can look at some homework problems, so that at least uh, we have gone through them sort of together, so that you know what to expect when you get into those sections. Okay. Okay. So for now, let's go ahead and start back up our discussion. Last time we were talking about section 10.3, and I previewed it a little bit, and I'm sure it was a little bit strange, but now we're talking about slope intercept form of a linear equation. And so you might be given a linear equation and it looks like I'm running out of ink yet again. Not to worry. That looks like this. AX plus BY equals C, where A, B, and C are just numbers. Okay. And so one concrete example of that might be, this is actually called standard form. The standard form of the equation. And the way that you can identify the standard form is that the X and the Y are on the same side of the equal sign. So in this particular case, the X and the Y are on the left-hand side of the equation, where you just have a number over here on the right-hand side, okay, or a constant. That's why we put C. Okay, so a concrete example of that might be something like, let's go 4x plus 2y is equal to 10, right? So I don't have to know what the graph of this thing looks like to be able to identify that that particular equation that I've given you is in standard form, where you have a number times x plus a number times y is equal to some number. Okay, so that's how you identify standard form. But what we're going to learn about is we can convert standard form to slope-intercept form. And so we can take this equation, ax plus by is equal to c, and then somehow manipulate that equation so that we get it in the form y equals mx plus b, where now the variable y is isolated and everything else is on the right-hand side. So you may have equations that ask you, or you might have situations where it will be easier to answer the questions that you'll be confronted with in Hawks if you take your equation and you rewrite it so that you isolate the variable y. Okay, so if we wanted to make that conversion, so given the equation 4x plus 2y equals 10, the question might ask you to find the slope and the y-intercept. So what you'll want to do here is get this into slope-intercept form in order to find these two things that they're looking for, okay? So what we can do is take a look at that equation, 4x plus 2y equals 10. And we're really just trying to get the y by itself. So the first thing I want to do is move the 4x over to the other side. So how would I do that if I wanted to move the 4x to the other side of the equation?
Subtract 4.
Yeah, but specifically, you're subtracting 4x. Okay, we're going to take this 4x away from this side, which means we can subtract 4x from the other side as well. Notice that I've written the 4x off to the side on the right-hand side, because the 4x, I really can't take it away from 10 because this is a number or a constant term, and this is a variable term, so I can't combine them. I can take 4x away from 4x because if I had 4 apples and I took away 4 apples, then that would be 0. And I would be left with 2y is equal to, and we want to put this in slope-intercept form. So let me put the negative 4x first. And since this is a positive 10, I'm going to put plus 10. Does that confuse anybody or is everybody on board with that? Because remember, I'm trying to get this in the slope-intercept form, which is y equals mx plus b. And I'm almost there if this is my goal. All I need to do is somehow get rid of this 2. And since this is 2y, I can divide by 2. I could divide everything by 2 so that the 2 cancels out here. And I'll be left with y is equal to negative 4 divided by 2 is negative 2x. And then 10 divided by 2 is plus 5. Okay, so this would be my slope-intercept form. Okay, so it's y equals mx plus b. And here, the nice thing about getting the equation in this form is that what we've done is we were given an equation 4x plus 2y equals 10. So we were given a standard form 4x plus 2y equals 10. And we've converted that to slope-intercept form. Which is y equals, and we got negative 2x plus 5. And the question is asking for two things in particular. This question wants, 1, the slope, and 2, the y-intercept. So the nice thing about slope-intercept form is that we can find these things without actually graphing the equation. We don't have to make a graph as long as we have this version of the equation. Because the nice thing about slope-intercept form is that when we have y equals mx plus b, the number representing m is the slope of the line. And the number representing b, so b is the y-intercept. And remember, the y-intercept has 0 for an x value, and whatever this number is, that is going to be the y value, which is why we call it the y-intercept. So just by looking at this equation and comparing it to what we have here, I don't have to do any more math. I don't have to graph this equation at all. I can just automatically say that my slope, m, is equal to -2, because that's the thing that's next to the x, right? The m, that number, is the slope. And that means that my y-intercept, written as an ordered pair, is going to be parentheses 0, comma, whatever this number b is, and it turns out that it's +5. So that's all the question's asking you for. So if you have an equation and it's given to you in standard form, you can manipulate it so that you get slope-intercept form, and then you can answer these questions without actually graphing it. So we don't have to go through the whole process of making a table and then choosing x values and then figuring out what the y values are. We can just basically pick those numbers right out of this slope-intercept form of the equation, and that will be our answer. Does anybody have any questions about that?
Can we make another example, please?
Sure.
Thank you.
Sure. So let's do another example. So example 2. Find the slope and y-intercept of the line given by, and then they'll give you the equation. So maybe I'll give you -2x plus y is equal to 3. Okay, so right off the bat, you'll notice that this is in standard form. If I rewrite the equation, -2x plus y is equal to 3, I could say that this is of the form ax plus by is equal to c, right? That's standard form. And we want to switch that somehow to y equals mx plus b. Basically, we want to get the y by itself. So to begin to do that, I'll look at this equation and say, well, I can get the y by itself if I just move the -2x over to the other side somehow. Okay, but that's where you have to remember your rules of algebra, the addition rule or the addition principle that we learned a few sections ago, which tells us I can move this -2x if I want to, but I'm going to have to do the opposite of what I see here, and I'm going to have to do it to both sides of the equation. So I'll add 2x to both sides of the equation. And again, don't be fooled right here. Just because I put the 2x below the 3, I'm not actually going to add these because these are not like terms. So you have to remind yourself that these are not like terms. So I can't add them. It's like apples and oranges. So I know that these will cancel out because they are truly opposites. Negative 2x plus 2x is 0. So I'll be left with y is equal to, and then I'm just going to rewrite both of these terms since I can't combine them as 2x plus 3 because this was a positive 3. Does anybody have any questions about that part? Okay, so once I've done that, the y is by itself. So this is in the form y equals mx plus b, where now my slope m, that's the 2. Okay, and the y-intercept which is usually written as 0 comma b, is going to be 0 comma 3. So what I can say is that, Hawks will say, what is the slope of this equation? Or the slope of the line is 2. And the y-intercept is the ordered pair 0 comma 3. So all we're doing is manipulating this equation to get it into slope-intercept form, and then I can automatically just take these numbers. The one next to the x is your slope. The one that doesn't have a variable next to it, the constant, that's going to be part of your y-intercept. And for the y-intercept, again, just to briefly remind you of what we covered last time, the y-intercept always has an x value of 0. Because if we were looking at this graph, and again, it's not asking you to graph it, so you don't have to do that extra work if you don't want to, but the graph of this equation, if the y-intercept is at 0 comma 3, then it'll be up here 1, 2, 3, and I'll have a dot right there. And then the slope, if you briefly remember what we were talking about last time about slope, we're going to cover that again here in a bit. Slope is the same thing as rise over run. So if I have a slope of 2, I can write that as a fraction as 2 over 1. So the slope is telling me that if I start at this point right here, I'm going to rise 2. So I'm going to go up 1, 2, and then I'm going to go over 1. So I'm going to walk 1 in the positive direction. So I'm going to go up 2, over 1, and then put another dot right there. Then you can grab a straight edge and draw this line. Obviously, Hawks is going to do this for you, but draw a line straight through those 2 points. And so that's our equation right here. This line is represented by the equation y is equal to 2x plus 3, where this point is 0 comma 3. That's the y-intercept. Okay, but we're going to get into this here in a second. The question is only asking you find the slope and the y-intercept. So again, just brief recap. They gave you standard form, and you just want to get the y by itself so that you can take the m, the slope, and the b, the y-intercept, and just put those as your answers. Okay. So sometimes they won't give you the equation though. So sometimes Hawks will only give you 2 points. So we'll call those 2 points. Point 1 has the coordinates x1 and y1. And they'll give you point 2, which has the coordinates x2, comma, y2, right? Because they all have an x and a y value, an x and a y value. And so we're just using the subscript here to say that x2 is different from x1, right? These are just labels. We're not actually going to do anything with these numbers. Again, they're just labels. So to find the slope, given only this information, you're going to use the equation or use the formula m, which is the slope, is equal to y2 minus y1 over x2 minus x1. And that will give you the slope. Okay, so let me give you an example where they might give you 2 points and they'll ask you to find the slope. Okay. So they might say, find the slope of the line that passes through the points -2, -1, and 2, 7. So you'll have to ask yourself, what are they asking for? Again, they're asking for the slope here. And what did they give you? They gave you 2 points. So what you might want to do here in these examples is you'll label these 2 points and call this x1, y1, call this x2, y2. And then we're just going to throw these numbers into the slope formula that I've given you. So the slope is equal to y2 minus y1 divided by x2 minus x1. So here's where you're going to have to be very careful. When I plug these numbers in, I'm essentially going to put parentheses where those numbers should go. I have 2 numbers on top and I'm subtracting them. Okay, so I'm going to put the subtraction sign there just so that I don't mess this up. Then wherever you're going to plug in a number, you should put parentheses here to indicate that that's where you're plugging in a number. So then we need to figure out, where is y2 and where is y1, or what are those numbers that I need to plug in? So because I've labeled these points, and this is the first point given, and this is the second point given, then this y value, 7, has to be y2. So I'm going to put a 7 right there, because that's y2. And then y1 should be -1. And be careful here. This negative is already here, but you still have to plug -1 in. So I am going to put -1 right there. Is everybody okay with that? So this minus sign is part of the formula. This -1 is here because that's what y1 is equal to. y1 is -1. And I need both of those negative signs. Otherwise, I'll mess up the problem. Next, x2 is going to be this number 2. So I'm just going to plug a 2 right there. Minus x1. So I have minus x1 goes here. X1 is -2. So I'm going to put a -2 right there exactly because that's what x1 is. X1 is -2. So I need to put -2 there. Okay. So as I continue to simplify this, if I subtract a negative, that's going to be the same as adding. So the top is really going to be 7 plus 1 because a negative and a negative makes a +1. Then on the bottom, I'll have 2. And if I subtract a negative and a negative makes that a +2 as well. And then I can go ahead and simplify this. So on top, I'll have 8 over 4. And finally, 8 divided by 4 is just 2. So that's the slope. Okay, so now I'm sharing with you guys my screen so that we can see a problem like this that you'll be confronted with in Hawks. Okay. It says determine or find the slope determined by the following pair of points. Okay, can everybody see my screen?
Yes.
Okay, good. What you're going to do here is we just want to label the 2 points that they gave us. So in this instance, we have x1 is equal to -1 and y1 is equal to 8. Okay, that takes care of the first point. The second point gives us x2 and y2. So x2 is going to be 6 and y2 is going to be 7. So if we're now looking for the slope formula is y2 minus y1 over x2 minus x1. So again, I like to set this up with parentheses just so that I don't mess up the negative because that happens quite frequently. And so you'll have to take care so that you don't accidentally lose a negative sign. And then we'll plug in, y2, which is 7, and then y1 here, which is 8. We'll plug in x2, which is 6, and x1, which is -1. So anytime you see this negative, you're going to want to go ahead and simplify that so that, okay, on top it's just 7 minus 8. There's nothing strange there. But on the bottom you have 6 minus -1, so let's just call that 6 plus 1. When we simplify that, 7 minus 8 is going to be -1 on top over 6 plus 1 should be 7. This fraction cannot be simplified, or it can't be simplified any further, rather. And so that has to be our slope. Does anybody have any questions about that part? Or about this question? So then I'll go ahead and type this into Hawks, -1 over 7, and we should be good. Okay, so when you're given 2 points, you want to just use the slope formula to find the slope. And then this next question in the homework, right, is more similar to what I said before, that if this is in slope-intercept form, and remember slope-intercept form is y equals mx plus b, where m is equal to the slope and the y-intercept is the ordered pair 0, comma b, can anybody tell me what the slope is if you're given this equation?
3.
Yeah, it's just 3. And can anybody tell me what the y-intercept should look like?
0, comma 5.
Yeah, we'll throw that in parentheses, 0, comma 5. And again, we're just reading that right off of the equation. So when we hit submit answer, there we go. You don't have to make that any harder than it needs to be, right? It'll take a little bit of practice to get used to it, so you get more familiar and more comfortable with it. But it really is like if they've given you the equation in slope-intercept form, you're just taking those numbers right out of the equation. You just have to remember which number is the slope and which one is the y-intercept. So the slope is always the number that's next to the x, as long as it's in slope-intercept form. Okay, so this is an example of asking you to graph the line now. And what we're going to do here is there's 2 ways of graphing this. So let me just write this equation down and we'll work with this example. So example from Hawks is y equals 3x plus 5. And I'm going to stop sharing my screen. And we're back to pencil and paper, right? So we want to graph this. And if we want to graph this equation from section 10.1, I said we would need to make a table, an XY table, find the ordered pairs that satisfy the equation, plot the points, and then you're going to draw a line through them. Okay. And we can do it that way. But if we're given this equation in slope-intercept form, it's going to be easier to graph it than doing this process. So we could do this process, and I'll go ahead and do it that way. I'll make my XY table. And then remember, you get to choose whatever X values you want. And I said, always choose something that's relatively easy for your X values. So I would choose 0 for the first one, and then I would choose something like 1 for the second number. It doesn't matter what numbers you choose here. Again, they will both work for the equation as long as you do the math correctly. So then we could say that y is equal to 3 times 0 plus 5, because I'm plugging in the 0 here for the x. And when I solve this, 3 times 0 is going to be 0. Then I'm going to add 5, and that's going to be 5. So that will be my y value right here. So I'll have 0, 5. Well, that makes sense because slope-intercept form says that 0, 5 should be my y-intercept. So here's my y-intercept. And then I could plug this one in just to get an arbitrary point and say that, okay, the new y value is going to be 3 times 1, because I'm replacing the x in the original equation, plus 5, right? So 3x plus 5, 3 times 1 plus 5. And then I'll go ahead and solve this. 3 times 1 is 3, plus 5 is 8. So that's my y value here, 1, 8 is the completed ordered pair. So now if I'm graphing this thing, I'm going to count by 2's in the y direction. So I'm going to count 2, 4, 6, 8. And I'm just going to count by 1's in the x direction. So 1, 2, 3, 4, 5, 6. And then we'll see, we'll plot these 2 points. I need to be at 1, 5. So 0, 5. 0, 5 would be right here. That's 0, 5. And then I need to be at 1, 8, which will be right here. That'll be 1, 8. And then I can draw a line passing straight through those 2 points. So let me get my pencil as my straight edge and my highlighter to draw this line. I'll try to hold everything straight and then go right through those lines, or right through those points. Okay, and that's good enough for government work. So that's one way you can graph it using the technique that we learned from section 10.1. You're just taking x values, you plug them into the equation, and then you can find 2 points, and that's all we need for the line. But there's something interesting about this slope, right? So the slope of the line, if you look at this, right, the slope should be 3. And we said that if I put this as 3 over 1, that's going to be the same as rise over run. So that tells me that I should go up 3 and over 1 to get to any other point on the line. And if I was at 5 here, and if I walked up 3, I would walk up 3, 1, 2, 3, again, because I counted by 2's here. And then if I walked over 1, I would get to this point. So there's something about the slope that if I have this one y-intercept, the y-intercept and the slope is all I need to graph the line. And that's really nice because if we're given an equation in slope-intercept form, then we'll have the slope and we'll have the y-intercept. We'll be able to plot the y-intercept and then use the slope definition of rise over run to get to the next point. Okay, so let's take a look at what that would look like. Well, using this same example, So we're given the equation y equals 3x plus 5. And we can use the slope, or rather we can use the y-intercept and the slope, which is the same thing as rise over run, to graph the equation, or to graph the line more efficiently. So we can avoid choosing random x values and plugging them in and then solving that to get the y values and then plotting the points. Okay, so what I mean by that is, let's start with our Cartesian coordinate system, right? I'm going to draw a graph. I'm going to do the graph roughly the way I did the last time. So I'm going to count by twos in the y direction, 2, 4, 6, 8. And so everything in between is going to be like 1, 2, 3, 4, 5, 6, 7, 8, right? I'm going to count by ones in the x direction. So 1, 2, 3, 4, 5. So these are going to be the steps. If you're given the equation in slope-intercept form, the first step is plot the y-intercept, 0, b. In this case, 0, b is going to be 0, 5 is the y-intercept. So I'll go start at 0, go up 5, and I'll be right here. The second step is to use the slope definition of rise over run to move up or down however many spaces the rise tells you. So with the rise, and move left or right with the run. Okay. So if the slope that's given in this equation, if the slope is 3, and we sort of need that as a fraction so that we can use the rise over run definition, then we'll call this 3 over 1. So that means we need to rise 3 and run 1. And since this is a positive, I'm going to count up 1, 2, 3 spaces. So I'm going to go up 3, that's the rise. And then I'm going to go over 1 space, so plus 1 run. And that is where my new dot is going to be. And that dot should be at the location 1, 8. And just like we did last time, since we have those 2 points now, I can draw a line straight through those 2 points. So this method only has 2 steps for plotting, as long as they've given us the equation in slope-intercept form. Okay, so what will that look like in your homework? Well, this is the exact same problem we've been working. And we can plot by just clicking in the graph space, right? So if I know that the first point should be at 5, then I'm going to go to the y-axis right there and put a 5 there. And you can zoom using this by double clicking. I can disable the zoom to get out of there. If you put the point in the wrong space, like I did, I accidentally put the point somewhere, you can just grab it and then drag it somewhere else, okay? But we need to figure out where to drag this to, and I said that we can use the slope to say that we need to start at this first point at the 5 and then go up 3 over 1, and that should be the line that we're working with there. Okay. Okay, so you have these other questions that say, find the equation of the line. Consider the following y-intercept and slope. Find the equation of the line for the y-intercept and slope given above. So this is sort of like going backwards. So let's do this example. Consider the following y-intercept and slope. And then they'll give you 0, -1. And because this first coordinate is a 0, I know that's the y-intercept. And then they say the slope is equal to this, 4 over 5. So let me stop sharing so that we can just look at the pencil paper. Okay. It's saying find the equation. Find the equation of the line having the y-intercept and slope given. So it wants you to find the equation of the line that has these two properties. Okay, so if we know that this is 0, -1, that's the y-intercept, I know that's the y-intercept. And I know that the slope is 4/5. And I know that the equation of these lines is y equals mx plus b. That's the general equation. Then the slope here is the m. And this number here has to be the b, because that's the slope and the y-intercept. So all they're asking you to do in this problem is to plug these values in for m and b. So your answer will be y equals 4/5 x, and then it's plus b, but since it's a -1, we're just going to put -1. And that's the answer. This is the equation that has 4/5 as the slope and -1 as the y-intercept. Does that make sense? Or are there any questions there? So again, this is the equation in slope-intercept form. So if we're given the intercept and we're given the slope, we can just plug those numbers into the general formula for the equation, and we'll have that specific equation that passes through this point and has this slope. So let's take a look at the homework again, right? If I know that they've given me the, if I know that they've given me the y-intercept here, and I know that I want y equals mx plus b, then the b must be the -1, and the m they've already given me. So I'm just going to type into this equation or into the box y equals, and then I need a fraction because I need 4/5 x plus, I'm sorry, not plus, -1 because that's what b is, and then submit the answer. So we should have gotten, we should write that on our piece of paper, right, as 4/5 x minus 1. Okay, that one's not too bad, but I think that it's maybe deceptively simple. So let's do another one. Okay, again, it's asking for an equation where they want you to just plug in the y-intercept and they want you to plug in the slope. So if the general equation is y equals mx plus b, and they've given you the y-intercept and they've given you the slope, then your job is just to write it out with the slope here. So 5/4 times x, and then plus 4, because that's the b right there. And then all you're going to do is type that in. X plus b.
Is it plus or minus?
Well, this one says 0, comma, +4. So you're going to put +4 because it's a +4. If it was a -4, then you would put -4. Good question though.
So we're always gonna keep the sign of the I guess
Of the y-intercept, yeah.
the y-intercept. Okay.
Yeah. And let's do another one, right? Let's just get real comfortable with these. Because I'm just trying to show you that it seems deceptively simple because it is that simple, right? You don't have to think too deeply about these. If the general formula is y equals mx plus b, can you guys tell me what the equation is supposed to look like here?
Y equals 1/5 x
1/5 x
plus 4.
plus 4. Yeah. And there's nothing more to it. So I can go ahead and type that in as 1/5. Don't forget the x plus 4. Submit the answer. And you can just do that all day. Right? And you will have to do it all day. I mean, you won't have to do it all day, but you'll have to do it enough so that you get comfortable with it. Right? So that you know, based on this type of question, that's all they're asking you to do. Right? Again, looking at this one, can anybody tell me what the equation is supposed to be? And I always write the general equation, the general form, just to guide me.
It's y equals 1/2 minus 1.
1/2 what? Don't forget the x. Minus 1. But yeah, that would be good. So that would be y is equal to 1 over 2x, and then minus 1. So the only thing that we're plugging into the general formula is the number for m and whatever the number for b is. You're going to leave the y and the x alone. Those need to be in the formula. If you forget the x, you'll get it wrong. Okay. So just be careful about that. Submit the answer, and then you should be good to go. Okay, let's look at what the next question looks like. Oh, so the next question is asking you to graph it. Okay, so at this point, based on this information, we know that the equation should be y equals 1/2 x minus 1. And so this first point they've given me, I can just plot that point directly on my graph. So I'll scroll down here, and it looks like they've already given me the y-intercept, right? So I don't have to plot that. But what I'll have to do is use the slope to get to my next point. So you can think about the slope, again, as rise over run. And so this particular slope that they gave us, this particular slope is 1/2. So this is telling me to go up 1 and go over 2 spaces to get to the next point. So I should be able to start at this point at the y-intercept. I'm just going to go up 1 and then over 2, and then that's where I'm going to click. And as soon as that second point is dropped, it'll generate the line for you, and then you can just hit submit answer.
Isn't it -1?
Which one? Are you talking about for the slope?
For the y-intercept?
Yeah, and that's why the y-intercept is right here. Right, the y-intercept they put right there, and what is this point right here? It's down 1, right? So it's 0, and then they went down 1. So they had already plotted this one for you. But when you use the slope, you're using this information here to go up 1 and then over 2 to get to the next point. That make a little bit more sense?
Yes.
Yes, thank you.
Yeah. Well, let's try a similar one, right? So now they've given us a different y-intercept and a different slope. But what I'm hoping to get across to you guys is that if you're given that information, you're given quite a bit of information. The equation that we should have then is y is equal to 1/6 of the slope x plus 3, because that's the y-intercept right there. And that's really nice because they plotted this first point in the graph at the location 1, 2, 3. It's 0, 3. So they've already given us the y-intercept right here at 0, 3. That's already done. So the slope, which is 1 over 6, that's your rise over run. So that's telling you to go up 1 from that point and then go over 6. And those are both positive numbers. So I'm going to start at that point, go up 1 to here, and then I'm going to go over 1, 2, 3, 4, 5, 6. And that's where I'm going to put the point So when I click right here, it should generate the line, and that should be my line. And let me erase some of this just so that you can see it a little bit more clearly, right? Do you guys have any questions about that? Again, I feel like this might be deceptively simple, but if you have questions, I want to hear them out.
Can the 1/6 ever be negative?
Yeah,
And if so, would it be the opposite? Would it go the opposite, or?
yeah. So
I know it's a different, but
no, that's a really good question, right? And I'm hoping to get an example that looks like that. So let me see if we can find an example. Try similar. Okay. Well, I want to get a negative slope, so let me try a similar and see if they'll give me a negative slope. Well, since they're not doing it for me, let me come up with an example for you. Okay, so let me stop sharing with you guys for a second, and let's just do this on old-fashioned pencil paper. So we want to find the equation and the graph of the line with the following y-intercept and slope. So let's say that they gave you a y-intercept of 0, -5, and a slope equal to -2/3. Okay. So on Hawks, you'll be given your graph space like this. And I'm going to try to be liberal with this, and I'm just going to count by 1. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6, -7. Okay, let me sort of raise this up so you guys can see it a little bit better. Okay. So the first thing you want to do is write the equation, right? And the equation here is going to be written in the same fashion. We have the m and we have the b. So we can write this as -2/3 x -5, because that's a -5. Okay. Is everybody okay with the equation part? Or rather, is there anybody who's not okay with the equation part or has any questions about that? Cool. So then we can plot this first point that they gave us at 0, -5. So we're going to start at 0, and then we're going to go down 5. So here is 0, -5. Okay, so we have plotted that point, but now we want to use the slope to get the next point. And since the slope is rise over run, you can think of this as -2/3. There's only one negative sign, okay? So be very careful with that. A lot of times students will make the mistake of saying this is -2 and -3, but there's only one negative sign. So I would say the negative sign goes with the top number, okay? So what this is telling you is that you're gonna rise -2 and you're gonna run +3. So if rise controls up and down motion, we're going to start at this first point, and rise is telling us not to go up, but to go down 2 points. Does that make sense? So we're going to be at -5, and we're going to go down to -7. and that'll take care of the rise. And then we're going to go over 3, and we're going to go in the positive direction. So if I'm going over 3, I'm going to count 3 this way, and I'll be right here. So really, I went down 2 over 3, and the line is going to go right through those 2 points. Again, Hawks is going to generate this image for you. My finger got in the way. Okay, and that will be our line.
So anytime it's a negative, we're gonna go down instead of up, correct?
Yeah. But notice that, okay. Notice that here I said the slope could be thought of as -2 over 3, where you're going to go down 2 and you're going to go to the right 3. And I said that it's true, there's only one negative sign. But notice that we're running out of space down here. Like if I wanted to go down 2 more and then over 3, I would still be on the line, but I didn't sort of extend my Cartesian coordinate. I didn't extend my y-axis down low enough. So if I've run out of space, there's a neat trick that you can do to get rid of that problem. And that is, instead of putting the negative sign on the top, -2/3 with the negative on the top, we could put a +2 on the top and the negative on the bottom. And that's going to be the exact same thing. As long as you only have one negative sign, this will be a negative number. So this would tell you to go up 2 and then go left 3. So if we started at this point here, at the very first point that they gave us, and we went up 2, but we went left or back 3, we would still end up on the line. So hopefully I drew this line good enough. 1, 2, 3. Boom. -3. Because these are negative numbers. So we can go up 2 and back 3, or we could go down 2 and forward 3. So if I've run out of space down here, then I can just reverse the process and go up and back, because that positive and that negative will still be a negative number. Okay, so the takeaway there is that if I have negative in front of the fraction, that's the same as having either the negative on top of the fraction or having the negative on the bottom, but you will not have the negative for both. These are all the same, but you should only have one negative sign. Okay, so let's take a look at some of the other problems in the homework set. Let's skip that one. Let's go to the next one. Okay. Now this one takes a little bit of critical thinking, but it's really just asking you the same stuff that we've been dealing with this whole time, right? It just sort of gives you a real world application or a real world example of where you might see this kind of math. So in business math, sometimes you have to, like, say AT&T wants to know how many internet users they have and how that has changed over time. Okay, so the given table shows the estimated number of internet users from 2000 to 2010, and the number of users for each year is shown in millions. So in the year 2000, there was 150 million internet users. In 2004, there was 200 million internet users, and so on. Okay, it says plot these points on the graph. So this is really plotting these points like we did in section 10.1, where we just want to look at our graph and go over to wherever 2000 is. I'm assuming that if this is 2001 and 2002 is here, that they're counting by twos. So 2000 would be this first line, and 2000 had 150 million users. So I'm going to put a dot right here at 2000 and 150 million. And it says to plot all of them. So I'm going to go to 2004 and put 200. So I'm going to go over to 2004. Then I'm going to go up to 200. And I passed it and put a dot right there. 2004 and 200. 2006 and 225. 2006 is right here. Going to go up to 225, which would be up between 220 and 230. And again, if you get it wrong, you can always drag it over and then drag it up to get to the right place, right? But this is just asking you to plot these points. So 2010, 235. So 2010 is the last one. 235 will be right there. Okay, so it says select the location on the grid, use the space bar or your to sort of click where the points can be. The points can be dragged using the arrow keys. So you could also use the arrow keys if you wanted to manipulate this. And then once they're plotted, select draw a line segment. So this is where reading the instructions are going to be really crucial. We'll put a line segment in between them. So there's our line, and then we're going to hit submit answer. Okay. So that's just a following the instructions sort of problem here. For this problem, again, another application problem. It says find the slope of the line segment that represents the change from 2006 to 2010. Okay. So let me write this data down and we'll sort of work with it and see what the question is actually asking us. So we have the years. And we have internet users. In millions. And all they're asking us about is finding the slope or that represents the change in internet users from 2006 to 2010. So we just need the data for 2006 and 2010. And since these are like ordered pairs, all I need is 2 points or 2 sets of ordered pairs in order to find the slope of the line segment between those 2 points. So if this is 225 million there, and this is 235 million there, and we want to find the slope, well, the slope formula is y2 minus y1 over x2 minus x1. Okay, so let me stop sharing for a moment. So you're going to have this formula on hand whenever they ask you find the slope given these 2 points. And then what you'll do is say, you know, this is our x and this is our y table. So this is x1 and this is x2. And this is y1 and this is y2. So we're just going to plug these into our formula. And this is a problem that mathematicians or math educators will say is just a plug and chug, because you're just going to plug those numbers in and then you're going to chug along and just solve the problem. So y2 is 235 minus y1, which is 225, over x2, which is 210, 2010, minus x1, which is 2006. And then if we do the subtraction, this should only be, what, 10? And down here, the difference between 2010 and 2006 is just 4 years. So then we can simplify this fraction and call it 5/2. But it really depends on whether this problem is asking for a decimal or not, because 5/2 would be the same thing as 2 goes into 5 2 times, and then you'd have half left over. Okay. I did that in my head, but we could do that in the calculator. 5 divided by 2 is 2.5. Okay, so let's take a look at the question again and see how it's asking for the answer. So it says find the slope of the line segment. So we use the slope formula to do that. That represents the change in internet users from 2006 to 2010. Okay, those are the only 2 data points we were looking at. Round your answer to 2 decimal places if necessary. Well, 2.5, it only has 1 decimal place. So we don't have to worry about rounding. We can just put this in as 2.5, and then you let go and let God. You just hit that submit answer and just let the cards fall as they may. And we got green, so that's correct. That's all we had to do. Just use those 2 years and the 2 sets of internet user data, and then plug that into the slope formula that I've given you, and that's how we're going to get our answer there. Okay. So there's other kinds of equations here that we need to talk about. I think we mentioned it briefly at the end of class last time. We talked about horizontal and vertical lines. So it seems like we'll have to review that just a little bit, because there's going to be some questions here about vertical lines and horizontal lines. So let's do a brief aside and talk about that stuff. So vertical lines have the formula x is equal to some number. So if you see an equation with x but not a y variable, the graph will be a vertical line. Okay, so for example, I'm going to give you a few examples just so we get used to this concept. If I gave you the equation x is equal to 3, then you have to be able to say, okay, there's no y in this equation, so x is equal to 3 would be right here on the x-axis, right? This is where x is equal to 3. And since I know that this is a vertical line, because there's no y variable, I'm just going to draw a straight vertical line that passes through that x value. There's something interesting about vertical lines, and that is that all of the x values will be the same value of 3, because this isn't moving over to 4 or 5 or 6, right? We don't have a line that's passing through all of these different points. It only has an x value of 3. So if you wanted to make a table of something like this, an xy table, the x is always going to be 3. So x is always 3. And the y can be whatever you want, right? I could say that the y is 1, and then we would have a point right here. Or the y is 2, 3, 4, 5, and then we'd have a point right here. Or we could say negative 1, 2, 3, 4, and then we could have a point right here. But the y value doesn't matter. It's going to be whatever value you want it to be. 1, 5, negative 4. All of these ordered pairs will fall on this vertical line. And when we have a line that's perfectly vertical, we say that we can't really measure its steepness, that the steep or the slope or the steepness of this thing is undefined. And that is the case for all vertical lines. Another example might be x is equal to negative 4. So if I were to graph this one, where I have 1, 2, 3, 4, that would be positive 4. 1, 2, 3, 4, 5, 6. This would be negative 4 right there. If I have this equation, then I know my vertical line is going to be passing through this x value, so I should have a vertical line going like that. Again, I know it's vertical because there's only an x and there's not a y. And if I wanted to get a table of ordered pairs, this equation is telling me x is always negative 4. So I can make a table the same way I did over there, where I can just put negative 4 for x. That's never going to change. And the y value, it doesn't matter what y values we choose. We could choose 0, we could choose negative 3, we could choose 7. And all of these ordered pairs would fall on this green line that I drew. So like I said, we could go 0 to negative 4. That's a point right there. Negative 4, negative 3. So I would go negative 4 and then down 3. So 1, 2, 3 right there. That's on the line still. And negative 4, 7 would be negative 4 and then up 7. So 1, 2, 3, 4, 5, 6, 7 would be like right here. And all of 3 of these points satisfy this equation, right? That is, all 3 of these ordered pairs fall on the vertical line. And again, if I asked you what is the slope of this line, I would say that the slope here is undefined. Okay, so you're going to get questions in Hawks that will ask you, okay, consider the following linear equation, x equals negative 1. Identify if the given line is horizontal or vertical and give its slope. Okay, so because this equation has x is equal to negative 1, I know that it doesn't have a y. So what I'm going to, what you're going to need to do is identify that there is no y variable. And then that's going to have to lead you to the conclusion that this is a vertical line. And all vertical lines have a slope which is undefined. Boom, boom. And then you'll just submit the answer. Okay, let's do another one, just to see how, again, deceptively simple it is. Okay, so we have this x is equal to 6. So if I wanted to graph it, I could, and I would have 1, 2, 3, 4, 5, 6 that's where positive 6 is. And the graph would just be a straight up and down vertical line right there passing through 6. So because I don't have a y variable, then I know that's a vertical line, and a vertical line always has undefined as its slope. Again, there's no tricks here. It's just straight facts, right? Does anybody have any questions about these kinds of problems? Is anybody curious why the slope is undefined? Okay, well, I'm going to tell you anyway if you're not curious. Let's think about that for a second, right? Like we said that we can find the slope if we have 2 points, y2 minus y1 over x2 minus x1. So like I said, we have this point right here at 6, 0. That's fine. And then we said we could go to 6, 1. That would be fine too, as long as the x is equal to 6. So if I think about those 2 points and I plug them into my slope formula over here, y2, let's call this point 1 and point 2. Okay, so point 2, y2 is going to be 1 minus 0 over, and then we'll have 6 minus 6 on the bottom. Well, that's going to be 1 over 0, and that's the problem here. We cannot divide by 0 because that gives us undefined. So because the x1 and the x2 are the same number and you're subtracting them, again, they're the same number, they're both 6, they're going to give you a 0 in the denominator here, and that's what makes this undefined slope. But the easiest way to solve these problems, right, is just to memorize that. And right, you can put this on your note sheet that you can use on the test, that all vertical lines have an undefined slope. And that would be maybe the easiest way to, get that question right when it comes to the homework and when it comes to the test. Again, we said that to graph this, we just need to go to x equals 6, and that's going to be 1 point right here. And as long as x is equal to 6, which is this vertical line here, I'm just going to go straight up, and it doesn't matter where I put the second point as long as the x is still 6. So that would be fine. This would be fine as long as it's a perfectly vertical line. As if you move it too far to the left, it's no longer perfectly vertical. If you move it too far to the right, again, it's sort of diagonal. You want this to be a perfectly vertical line, and so it doesn't matter where this is as long as you maintain that perfect vertical straight line. The only thing that has to be true for this line is that these points have to have x equal to 6. So this first point is at 6, 0, and that checks out because x is equal to 6. And this point right here is at 6, 8, 5, 6, 7, no, 6, 7, 8, yeah. And that one checks out because that one has an x value of 6. Okay. Now, these kinds of questions, they just give you a graph, but they don't give you points. And they're asking you to find the equation in slope-intercept form. Okay, so I find that these kind of equations are probably more complicated, or these kinds of problems are more complicated because they ask you to do a few things. So in order to get the slope-intercept form, so if we're given a graph, and we're asked to find the equation, we sort of have a laundry list of things that we need to find. So let's talk about that laundry list. So the first thing that you're going to need to do is find or identify 2 points on the line. Because we need x1, y1, and we need x2, y2 in order to find the slope, which is going to be the second thing that we need to do here. So the second thing we need to do is find the slope using the slope formula, which is slope is equal to y2 minus y1 over x2 minus x1. Okay. Then the third thing we're going to do is we're going to find the y-intercept using the slope m and the formula y equals mx plus b, because we're looking for the y-intercept, which is going to be b. So what I recommend is if you find the y-intercept first, well, actually, if we find the 2 points, then we can use those 2 points, and we can either find the slope using the slope formula or by rise over run. Okay. And I'll show you that in an example right now, right? Because once we have the slope, which is m, we can plug it into this formula. And once we have the y-intercept, we can plug that b into the formula so that we have our completed equation. Okay, so let's take a look at that problem that we have here in Hawks. Okay. So the thing that I recommend here is first we want to find the 2 points, right? So we want the first point ideally to be the y-intercept. So I'm looking for 0, something. And so if I look at my graph, I have this point right here that should be at 0, and we went up 1. So that's going to be a positive 1. Is everybody okay with that, or was that too fast? Okay, so that's the y-intercept. Again, that means that this is going to be our b. And then our slope is supposed to be rise over run. So what I could do is use this to pick some other point, right? Like this point right here looks really good. And I'm saying that it looks really good to me because it's passing right through one of these vertical lines and one of these horizontal lines, right? I can put a little plus sign right through it. And so again, we're just paying attention to the blue line here. So what I would tell you is that this is a really good point, or this is a really good point. And we just need 2 points that are on the graph. So I'm going to use this one, which is at 0, 1. And I'll use this point over here, which is going to be at 1, 2, and then down 4. So that's 2, -4. But in order to get to that other point, I went down. How many points did I go down? Let's see. I went down 1, 2, 3, 4, 5. So I went down 5, and then I went over 1, 2, plus 2. So my rise is -5, and my run is 2. So that's the slope of this line, -5 over 2. Does that make sense? Or is there any confusion there? Okay, so since I have, the form of the equation is going to be y equals mx plus b, and I have m right here, then my equation is just going to be y equals -5 over 2x, and then plus 1, because that's what my b is. So that's all I'm going to type into this equation box. Y is equal to, I'm going to make a fraction, put -5 over 2x plus 1, and that should be my equation. Do you guys want to do another example?
Yes, please.
Definitely, right? Okay. So like I said, it's really just these 3 steps. Find 2 points that the line passes through. Then we're going to use rise over run to find what the slope is supposed to be. And then we're just going to plug the slope and the y-intercept into the formula. Okay. So here they gave us a graph, and it should be a new graph, but I could try similar, right? Gives us a really different graph, right? So this might be a better example. So I'm just going to zoom in, and it looks to me like the first point that we want to choose is this one that's passing right through the y-axis. That's our y-intercept. Our y-intercept is at 0, 5. Okay, so I know that b is equal to 5. And then I just want to choose another point that the line is sort of perfectly going through. So to me, it looks like this point right here looks pretty good. So I'll put a little dot there just to know that's where I want to travel to. And then I'm going to use my slope, which is rise over run, to get there. So let's see how far I go up or down and how far over I have to go. So I'm going down 1. So my rise is -1. And then I'm going over 1, 2, 3, 4, 5. So I ran 5 in the positive direction. So my slope should be -1 over 5. And that's my m. So then you're going to put your general formula, y equals mx plus b. And you're going to leave the y and the x alone. And we're just going to plug in the numbers for b and for m. So m should be -1/5. That takes care of that. And the b here is this +5, so I'm going to put +5. So this should be the equation. So when you type that in, you should put y equals, and we're going to put a fraction, -1 over 5x plus 5, and we should be good. Anybody have any questions about that? Okay, well, let's see. Okay. So we talked about vertical lines, and this might be one of the last things that we need to cover here, and that is horizontal lines. So when I said we saw horizontal lines, or when we saw vertical lines with equations that only have an x. But horizontal lines, not the diagonal ones, are equations that look like y is equal to some number. And let me go ahead and stop sharing so we can just, yeah, look at the pencil paper stuff. Okay, so if you see an equation with a y, but not an x variable, the graph will be a horizontal line. So let me give you some examples. An example of that is going to be something like y equals 1. Okay, so if I draw a graph of this line, what I'm doing is I'm going to look for the y value of 1, which would be right here. I just went up 1. And because there's no x variable, that should signal in my mind that this is a horizontal line. So I'm going to draw a perfectly flat line right here. And so if we think about all the points that fall on this line, x comma y, this equation is telling me that y is always going to be 1. But the x variable can change. It doesn't matter what the x variable is, because if I went to x equals 1, and I went up 1, the point 1, 1 over 1 up 1 is still on my line. If I went over, let's say I went over 7, 1, 2, 3, 4, 5, 6, 7, and then I went up 1, the x variable didn't matter. If I go up only 1, then I'm still on the line, as long as the y value is 1. And I can even go back to -3 if I wanted to. So -1, -2, -3. And if I go up 1, I'm still on that horizontal line. So this ordered pair satisfies the equation also, because the equation is only telling you that y has to be 1, but x can be whatever. Okay. For these kinds of equations, because they're perfectly flat, imagine if you were walking on a perfectly flat surface. You would say that it has no slope, right? It's perfectly flat. So what you could say is that the slope is equal to 0. And this means perfectly flat, otherwise known as horizontal, perfectly horizontal. And you might ask yourself, well, why is this 0? Well, if I take these 2 points and plug them, any of these 2 points, and plug them into the slope formula, which is y2 minus y1 over x2 minus x1. And let's say that I use these first 2 points, where I call this one 0.1 and I call this one 0.2. So what I would do is plug in my y2, which is 1, over, let's say, so 1 minus y1. Okay, so y1 would be this one. And then x2 minus x1 would be x2 minus x1. So that's 7 minus 1. And if we simplify this, we get 0 over 7 minus 1 is 6. And 0 divided by 6 is just 0. So remember, you can have 0 on the top of the fraction and you'll get 0, but you can't have 0 at the bottom. Otherwise, you'll get undefined. But this is why the slope of a perfectly horizontal line is always 0. Okay. Another example of a line like this would be something like y is equal to negative 4. And if I drew that graph, the line should tell me to go down 1, 2, 3, 4 to negative 4. And then I'm going to put a perfectly horizontal line right there. It looks like I missed a little bit, but it's okay. Just pretend that I didn't miss. And so the ordered pairs for this line, for this separate equation, says that y is always going to be negative 4. And I can just choose whatever values I want for x. I could choose 0, I could choose 100, I could choose negative 1,234. It doesn't matter. Okay, x doesn't matter because x is not a part of this equation. And again, because this is a horizontal line, I know that the slope is equal to 0. I don't have to go through the math to know that. I could just memorize the fact that perfectly flat means a slope of 0. Okay, so that's what I needed to introduce in order for you to do this next kind of question, which it seems like I've gotten timed out of Hawk. So let's jump back in. And let me go to the student side. And let's, hopefully that will take us right into the problem we were just working on. Okay. So, like I said, this equation says y is equal to negative 2. So because there's no x variable, I know that this is a horizontal line. So there we go. And a horizontal line always has a slope of 0. So all you need to do is select horizontal and type in 0 here. And then you submit your answer and you call it a day, right? Or you go on to the next one, right? You don't necessarily call it a day, but it seems deceptively simple, right? As long as you memorize the fact that as long as there's not an x in the equation, it's a horizontal line. All horizontal lines have a slope of 0. They're perfectly flat. So let's do another one just to prove to you that we're not trying to trick you here. We're just trying to get you to memorize this fact, right? Like if I wanted to, I could ask you to graph this, in which case I would graph a line that, you know, I would go down 1, 2, 3, 4, 5, 6, and draw a line passing through negative 6, perfectly flat. Because again, there's no x. That tells me that this is a horizontal line, and the horizontal line is always going to have a slope of 0. Does anybody have any questions about this kind of question? Okay, and we just graphed this one. So like I said, you need to put 2 points. And since this is at y equals -6, the 2 points are going to be, you could do the y-intercept here at 0, -6. And then you could just do any other point as long as it's a perfectly flat line, right? You can move that point over here. You just need to make sure that it's perfectly horizontal, because if you put it a little bit too high, you're not going to get a perfectly horizontal line. So it still needs to be flat. Boom. Okay, so for a question like this, we did a question like this at the very beginning of the class, and that is asking you, determine the slope and the y-intercept for this equation. And just to refresh your memory, if this is in standard form, which is ax plus by equals c, then we need to change that to y equals mx plus b in order to find the slope and the y-intercept. So over here in the side, I'm going to do -9x minus 6y is equal to 12. And I'll want to add the 9x to both sides because I'm trying to get rid of it on the left-hand side. So that I have now -6y is by itself, and that's equal to positive 9x plus 12. Are you guys okay with that? The last step to getting this in slope-intercept form is you want the y completely by itself. So I'm going to cancel out this -6 by dividing by -6 on both sides. The -6's cancel here. So we'll be left with y equals. But now we want to reduce this fraction. So this is 9/6, which will reduce to -3/2. And we'll leave the x alone. And then 12 divided by -6, this part, 12 divided by 6 is 2. And since we have a positive and a negative, that's going to be a -2. So now that this is in slope-intercept form, y equals mx plus b, and I'm playing it really loose with this plus or minus, right? Then that means I know that the slope here must be -3/2, and the y-intercept is going to be 0, -2.
Do you have to put the x and the slope or no?
Oh, here?
Yes.
For the first box?
Yeah.
No, for the slope, it's just the m. It's just the number next to the x. So you don't have to put the x. You're just going to put this number. But for the y-intercept, you will need to put 0, b in parentheses.
Got it. Thank you.
Good question. And then we'll just hit submit. Boom. And that basically takes you through that entire homework, right? So I actually, want to stop there because I know that we did a lot of different things about slope-intercept form. And so the only way that you guys are going to pick it up is by getting into Hawks and working on that homework yourself, struggling with it, asking questions, talking to me about it, and talking to the tutors in Math World. So make sure that you're making time to work on that stuff, and also make time to go into Math World and talk that stuff out with either myself or with one of the other tutors, right? Because I'm thinking that next time we'll go ahead and finish up, we'll start and finish section 10.4, which is a different form of a linear equation. So far we've worked with standard form and slope-intercept form. Section 4 is point slope form, which even though the name sounds familiar, it's a different form that we're going to have to get used to. Okay. So I want to cap us off here at slope-intercept form. Make sure you get that practice. If you're having trouble with it, send me a message. Come to Math World. Because section 10.4, what we'll cover next week on Monday, that is the last section that we're going to cover in chapter 10. So we're having a test following that. Okay. And I'm going to have to look at the calendar because I don't think that we'll have enough time for you guys to have a review day before that test. I'll take a look at the calendar and get back to you. But if we have time, we'll have a review day on Wednesday and we'll have the test the following Monday. Okay. But if there's not enough time, the test will be next Wednesday. Okay. So we have one more section to cover and then the test. So make sure you're getting in there and getting the practice that you need. Does anybody have any questions for me?
So the test is on the 11th?
I have no idea what days we're even. So what I'm saying is that it will either be on the 11th or it will be on the 16th, but I'll have to look at the calendar to plan that out. Does anybody have any other questions?
Are we gonna get another review on Hawks?
Yes, I'm going to be making a review. I hope to have that out to you guys before the weekend, so by Friday, to throw it up on Hawk so that you can start playing around with it. Right? We still have another section to cover, so you won't be able to do all of the homework problems in that review, but I just want to get it out to you guys so that you know you can get in there and start practicing.
I have another question. On the 11th, it's Veterans Day. We're still gonna have class, right?
Yeah, I'm pretty sure. Let me double check the calendar real quick. I have it pulled up over here. I'm pretty sure that Veterans Day is not a student holiday. That at the college level, at least. Yeah, it looks like the next holiday that we're gonna have is Thanksgiving weekend, which is the 26th through the 29th. Okay, so we don't have Veterans Day off. Any other questions? Okay, well, if you do have any other questions, you're more than welcome to stand by, but otherwise you guys are free to go. Get in there, get your homework done. If you have any questions, ask for help, don't be proud, get in there and get to work, okay? You guys have a good night.
Good night. Thank you.
Thank you.